we start with another video today that is logic gates. Now, what are logic gates? Logic gate is a digital circuit that follows certain logical relationship between input and output voltages and hence are called the logic gates. So this is the basic definition of logic gates. Okay. Then basically it performs a logical operations on one or more binary inputs and produces a single binary output. Okay. And we can say these are called gates because they control the flow of information. Right. Now there are 5 common logic gates used. So the first one is your NOT gate. The second is your OR gate. Third is AND gate. Fourth is your NAND gate. And fifth is the NOR gate. Seeing all of them one by one. Now, every logic gate is represented by a symbol and its function by a truth table. Okay. Now, what is truth table? Truth table helps us understand the behavior of logic gates. Now, let's proceed one by one on this. So, let's take the first one, the NOT gate. Right. Now, in NOT gate, first of all, let's discuss about the symbol. Okay. So, the symbol for this is okay. This is the most basic gate which with one input and one output. It produces one output if the input is 0 and vice versa. Right. Now we come to the truth table. So how do we define this? See, A is the input. So here we'll write A and here is the output which is like Y. So how do you define this? Okay. So when it is 0, the input is 0, you get Y as 1. Right. And when this is 1, it is 0. Right. So it produces an inverted version of the input at its output. And that is why it is called inverter. Right. And this symbol which you see, this is the inversion. This indicates inversion. Okay. So this is your first gate. Now we come on the second gate. That is your OR gate. Now again the same thing. Discuss about the symbol. So this is A. This is B. Because Y. So this is the symbol for OR gate. Now we come to the truth table. So again we'll make the same thing. Input and output here. Now here inputs will be A and B. And the output will be Y. Now here what happens? Suppose we put both the inputs as 0, 0. So you'll get the output as 0. Now when you put this as 0, the first one 0 and the second one as 1, you get the output as 1. Here also if this is 1 and B is 0, then again the output is 1. And for 1 and 1, again the output is 1. So the OR gate has 2 or more inputs. See, these two are the inputs here, these two, right? And the output is 1. Here, you'll get the output at Y position. Now, the output is 1 when either input A or B or both are 1s. So, see, either A, either B or both. All three are 1 and hence we get this. Plus, if any of the input is high, the output is high. That's what they want to say. Now, this operation is represented by A plus B. Y is equal to A plus B. So, this plus sign is used to show the OR operation. Okay. Now, we move on to the next one. That is your AND gate. Now, again, the same thing. We'll go for the symbol. So this is the symbol for it. An AND gate has 2 or more inputs and 1 more output. Now we'll go to the truth table. Now same thing. Here we'll put input, here we'll put output. Now here and here is your A and B. This is Y. Now what is the condition? When this is 0 and B is 0, the output is 0. When this is 0 and this is 1, still the output is 0. When A is 1 and B is 0, again the output is 0. And when both of them are 1, then you get the output as 1. So the output Y of AND gate is 1 only when all its inputs are high. This condition. Right? Now, a dot is used to show the AND operation. So, for here what we write, Y is equal to A dot B. So, this is how we represent the AND gate. Now we come to the symbol. See, this is AND gate, plus we put another inversion button over here, and this is Y dash. So till here it was a AND gate and plus here. So this becomes A dot B inverted. Right? So this mark is for inversion. Correct. Then we come to the truth table again. What happens over here is input and output. This is A, this is B. We come for Y and Y dash. Right. So now condition remains the same, 0, 0, 0, 1, 1, 0 and 1, 1. Now for AND gate, what do you get? 0, 0, 0 and 1. But here the sign is of inversion. That means now it will be inverted. 0 will become 1, 0 will become 1, 0 will become 1 and 1 will become 0. So the final truth table, if you have to make for AND gate, will be like this. If you have to make it, it will be A, B and Y dash will be 0, 0, 0, 1, 1, 0, 1, 1 and finally you will get 1, 1, 1 and 0. Correct. So this is a NOT AND gate, which is equal to AND gate followed by a NOT gate. So see, till here it is an AND gate. And then after this, we are inverting. See, this sign represents for inversion. right? The output of all NAND gates are high if any of the inputs are low. So this is what is about the NAND gate. Okay. Now we come to the last gate, that is the NOR gate. Now again the same thing. This is the symbol. And we get Y here. The symbol is an OR gate with a small circle on the output. The small circle again represents your inversion, right? This represents inversion. Okay. Now we come to the truth table. So the truth table will be again the same thing. Input. Here we go for output. Here it is A and B. And here it is Y and Y dash. So this is a NOT OR gate, which is equal to an OR gate followed by a NOT gate. So the output of all the NOR gates are low if any of the inputs are high. So I'll just show you this 0, 0, 0, 1, 1, 0, 1, 1. Now what should be the output here? 0, 1, 1, 1. But here we need an inversion of it. So 1 will be inverted to 0, 0 will be inverted to 1, 1 will be inverted to 0. So if we have to take the final truth table for this, it will be input. This is the output. Here you will find A and B, and here you will find Y dash 0, 0, 0, 1, 1, 0, 1, 1. And finally you get 1, 0, 0 and 0. So here it will be represented by A plus B bar, right? So this is it. And NAND gate and NOR gates are considered as the universal gates because you can obtain all the gates like AND, OR and NOT. Okay. Final one is thank you.